Hey, and welcome back to the Build It Basement. Today we're working again on our Voron 0.1, specifically on our AB drive on this printer. So A on one side, B on the other, Core XY, amazing printer, amazing functionality, small in stature, huge on performance. Not a lot of real parts in this printer, but it's still a decent build. Definitely a lot easier than the 2.4 if you're thinking about building a printer. You don't need something huge, and you probably don't, honestly. Consider a 0.1. Let's see here. If you haven't subscribed, go ahead and do so. If you do like the video, go ahead and hit that like button as well. I truly do appreciate it. If you can't watch it through its entirety, I appreciate that too. There are tidbits and information along the whole video, so if you skip around, you might miss something. So check it out. All right, no better time than the present, right? So, working on the Voron 0.1, looking at our screen over there, and we're working on the AB drive today. Got parts right here for assembly. We have our NEMA 14 motors right here, which are going to be called up a little bit later. I have not dug into this box of toolhead and motion parts, specifically on the motion parts there. We're not going to be doing toolhead today, but motion parts definitely. Got our assorted screws, all M3s on this. Some heat certs, so we're going to be doing some heat certs, right? Fun. And some printed spacers, which, yeah, I guess. These guys are pretty cool. I kind of actually, I don't know, I get excited about stuff like that. So if you get excited about stuff like that, then we're in the same boat. All right, so that, some tools, new camera setup. So up here we got a new Lumix camera. I got the Ace. Actually, that's not even right here. We got the A7 right here, the Sony A7. So new camera there. We got the Samsung G-Track mic. I've got, what else we got here? We got our new bench cam, which is just a Brio, but it's 4K. The whole stream is 4K. Every video source in my stream is 4K. So without, hey, look at that. Without any further ado, let's get into it real quick like. Do this, yeah. All right. If I haven't said it yet, I'm Kermit. I'm building Voron 0.1 and on with the show. So AB drive, Core XY printer, always have AB drive. Basically, it's a drive that is symmetry in motion. How about that? Yeah, so sometimes on Core XY, your AB drives are going to be opposing, which will actually cause your movements to be straight, or they will be concentric, so they will actually be moving at a diagonal when they are doing that. So first things first here, we got our parts. Let me go to a different screen real quick. Let's see here, screen, and we'll go here. We have, let's see, first I'm going to work on an A drive. So the Voron team, in all their wisdom, and I do mean that, wisdom, we're able to basically put in letters on these parts. And I think it's showing up, but just in case you can't see it, right there. And pardon the ghosting, printed these pretty quick, but they are very nice, toasty, tasty little morsels. So we're going to be working on A first, so let's get that. Let's go full screen on the screen. So we need our A parts. I'm going to pull them all down here side. I'll pull this side right here. I know you can't see what I'm doing, but trust me. And then I'm going to go back up to this, and I am going to get my soldering iron turned on. And we are installing some heat set inserts, or some heat certs. I don't know if I'm the only one that calls them that, but I call them heat certs. It's way easier. This particular ABS I print at about 250 degrees Celsius. So what I suggest is that you stay about 10 to 20 degrees lower than your print temperature when you're doing heat certs. That way you're not going to be driving things in, just turning everything into a pile of goo, you know? You want those to get in, you want them to grab, you want them to be nice. Yeah, so I'm at 365. I was obviously doing some soldering here. So 250, we're going to bring us down to about 235. We'll try that. I don't want to kill everybody's time watching me do heat certs, so we'll let that get down to that. While we wait for that, though, we will get some of these parts going. So what do we have here? We can go right there. So A drive parts. It's almost like one of those shell games, right? We can hide the parts. No? All right, good. I'll face them like this. I'm going to dump this bad boy out. And I know that these screws may be hard to see, and these parts may be hard to see as well. So I've got a really expensive, super high-tech compensation device. There, yeah. So if you're looking to get some of these compensation devices for your video, you can check them out. They sell them online at stores. Yeah. All right. So enough of the comedy, the dad humor, if you will. And let's go back up to the screen, and we're gonna go here. Actually, do I have? You know what I'd like is I would like a Sony. There. That's what I want. All right, so what I like to do when I'm working on these things is kind of put them in orientation that matches with what you're seeing up there. So what's up there, you want down here. That way you keep everything straight, especially if this is a first time build. You know, I go ahead and mention this right now, get it out there on the table. This is my first time building a Voron 0.1. And you know, there are tons of other videos out there, people building 3D printers, but most people that build 3D printers on these YouTube videos have done dozens of them. To the extent that, I don't know, I've watched some of them previously, and it just seems like you're watching the show more than the actual build. So I will tell you up front right now, I am not quick. I build this step by step. I do not do much editing, if any at all. And I possibly will make mistakes. But I will tell you that if I do make a mistake, that I will correct that mistake in a future video, or at least make notes of it in the description of the video. So keep an eye on that. All right, so back to this. All right, so our soldering iron is now where we want it. Bring it over here. On this, what I have is a heat set insert or heat cert. Oh man, so many S's, huh? S's. Tip. Now, if you don't have one of these, I got a video about putting in heat certs, but you can always go ahead and see if I get this to do what I need it to do. Yeah, right there. You can file down a cheap soldering tip like that, a pretty blunt one like that. And the reason why you want to do that, if you do that, is because you don't want that tip in the plastic. It will stink, it will make a mess, but worse than all of that, it will also offset that plastic, push it up, it'll be inside a heat cert, and your screw won't be able to make it all the way in like it should. Yeah, so on a heat cert inset, or heat cert, set insert, yeah. I'm gonna mess that up 16 times. I'm gonna call these inserts. We'll just be done with that. So right there is what you're looking at, and come on camera. Woohoo. You can do it. There we go. So really hard to show, but there is a side on that is smooth and a side that has like a warble on it. The warble side is up, the smooth side is down in, and it will basically kind of just sit there on the surface of your print if you've printed it with some decent amount of precision. I like to take my certs and line them up so we can just hammer them all in. So here we go. One thing to note specifically, this is a little bit different on this, so I'm going to point it out. On this video, on this page right here, they're talking about these two particular outer heat inserts. They are below the surface. I'm not quite sure at this point why they're below the surface. It's not common practice to put them that far below the surface. You know, flat with the top is kind of the norm, but we'll make sure we kind of countersink those just I don't know, probably a millimeter and a half or so. That's probably all they really need, but I just want to point that out since if I didn't, you might miss it. So here we go, and actually I'm going to get to, we'll go back to here. It's a good side view. Soldering iron is where we need it. We're at 235, and try to do so it's kind of at least visual. I'm going to do the middle one first because the middle one doesn't need to be countersunk. What I'm trying to do is kind of push this down at 90 degrees, straight up and down, and it shouldn't go down too quickly, but it should work its way down. Biggest thing on that is you want to make sure that it is relatively square to your piece, so you want that 90 degrees. Now if you're a little bit off, I was a little bit off there, you can kind of work yourself a little bit back and forth a tad. You know, the more you play with it, the more you're probably going to hinder the acceptance of that the plastic into the piece to an extent, but you can do some correcting. So these two, one to the far left and the far right, are going to be sunk below the surface per instrucciones. And there are some people that use a special doodad tool to put these in, but I'll tell you that these are not rocket science. They're pretty easy to put in. I mean, they're just pieces of brass. You heat them up, melts plastic, sinks into the plastic. Call it a day. Gives your screw something to grab onto, right? Alright, looking at that, just gonna look at it from a couple different angles. Looks good. Looks good all the way around. Perfect. Alright, set that aside. Get back to this. Okay, so we got those three in, and now they're showing us, they're saying identifying the right part. We already went through that. Now we're going to take this part, we're going to flip it around. So let's go ahead and flip that around. Yeah, we'll flip that around like that. We're going to take our, I'll call it a key. It kind of looks like key. One note on this real quick, that this right here is off, it's lopsided. It's more on one side than the other. The side with the thicker part is going to go down so that your top part is flush. So top flush, bottom side down, per that picture. And on we go. So A drive. All right, so we got another heat cert to put in. Now this one is actually going to go into the other piece of this, and it is going into the bottom of the, trying to work out my new buttons here. It's going to go in the smaller of the two holes here. The top one obviously is way too big. If you did try to put it in there, you'd want to put that right there. No bueno. So go ahead and put that in like that. And like I was saying earlier, you kind of can set them so they kind of hold themselves, and you know it's there. It locks in pretty decent. It's actually probably a good quick test to your print is if you can put your heat cert in there and it holds itself. I mean, you're not going to throw it around or anything like that, but just holds itself. And it didn't take a lot of pressure to put it in or anything like that. If it holds, you're probably golden. That's probably a decent print in terms of spec and size. Okay, so they want us to put that in. And another note I will make right here now is when you're putting these in, I like to hold I would never do it like this. Okay, it just doesn't feel right. Maybe you can do it that way, but I don't think I can. So let's go ahead, hold this vertical, put this one in, and it's not calling out anything about countersinking this overly or anything like that. So we're just gonna do our vertical standard push in here. All right, perfect. Note too, some people use a spatula or something like that, push down on top of that thing, make sure it's nice and flush, or they put it on the surface, push it down on a desk, something like that. But for the most part, you know, if it's in there and it looks good, I mean, it doesn't need to be 100% precise. So don't, you know, precision does count, but it counts when it counts, and then, you know, when it doesn't count, you're just wasting your time. Spend your time working on things that do count. The more you know. All right. So we're gonna go. Let's see here. So we're gonna do M335s. Now I know M335s are the longest screws that we're using for. That's my B drive. Don't want to mess with that. M335s are the longest screws that we're using for this portion of the build. And let me put them on our super contrast magnification device. So M35 is the longest, so I'm gonna grab 2 of those. They are my longest screws. I couldn't measure them. You know, we can grab some calipers. We can take them and kind of see exactly what they're at. All this stuff, and you know what? If you got time to do this with every screw, man, I wish I had your time. But yeah, we know these are the longest ones. They're marked in my little bin. I think they're 25, but I kept them marked in my bins. I keep the little packages they come in just for that. And then I label my stuff, because labeling takes about 5 seconds and will save you hours. All right, M35. Sorry about that. So it looks like we're gonna throw this guy right in here, and he's gonna drop right through. Slick. And this other one, where is that going? It's being held like that, and it is going through like that. So one through here, one through there. I go back to this camera right here so you can see that. So we basically just pulled off the amazing M3x35 BHCS procedure. Button head screw. All right, so let's look over here. We got note on shims. Specify shims have consistent thickness compared to regular washers. If you source washers instead, make sure to measure the thickness. Target is 0.5 millimeters to avoid issues with stack up. Most kits that I've seen come with actual shims, but you know, again, that's something where you want to be relatively exact, because you're dealing with mechanical properties right there with your stacks and stuff. But for the most part, we're dealing with plastic that we freaking heated up till it melted and bound it together. So don't drive yourself nuts. All right, so actually, while I'm doing this, hey, why don't we look at what's inside this magical box of toolhead motion? So first things first, nice Bondtech gears. We'll set that here because that's toolhead. We've got some grubs, or set screws they call them, grub screws, set screws. I've got some, oh, that's some more thumb screw assembly. That's going to go with that. That's going to be part of the mini afterburner. Then we got bearings. Is that what we're using here? We're using the F623. Yep, these guys. So we're going to need some of them. Let's see here. More grub screws. Set screws, grub screws. What do we got here? Some more bearings. We need any of these bearings. Nope. No bearing, those bearings. And we got belts. We got some Voron tube. We've got some pulleys. I do not see my shims. So let me see if I can find some shims. Shims. Shimmy. Shimmy. Shims here. Oh, shims. Shim washers. Ah, you can call them shim washers. All right, have those in a separate bin. Not an issue. Let's take a look at that real quick though. Since these are specifically being called shim washers, I'm kind of interested in knowing what the thickness is because of their little warning there. This is an LDO kit, so I've heard good things about LDO kit. I'm still kind of on the fence on the whole thing. I'll tell you that I built a Voron 2.4 previously with a FormBot kit, and I won't say I had more issues with that kit. I won't say that kit was better, but I also will not say this LDO kit is better either. So you play with those words however you want. All right, so what do we got? Uh-oh. Uh-oh, uh-oh, uh-oh. 0.48. If I squeeze it really hard, I get 0.45, but 0.49, 0.48, 0.49. Change that thickness. I'm just twisting, spinning that washer. So 0.48. So we are 2/100ths off. Oh no, it's not gonna make a difference. Honestly, not. So back to the screen of Sony. Here we go. So these stacks. So the first thing we're gonna do is we're going to wind up flipping this part upside down. And one thing you could do if you want to hold these screws in place is, because they're going to fall down when you put them down, you can put a piece of tape behind them if you want. That'll help. Or you put your fingers behind them like this. Just don't take your fingers out. And we're going to work on the stacks. So the stack with the large, get rid of that for now. The stack with the large portion, the backing on it there, that one actually is this one closest to us here. So it's starting with a shim or a washer, depending who you ask and what day of the week it is. So let's get that on there. Okay, and then it's got a 623 bearing. Let's open these guys up. Whoa. So let's take that whole package out. So make sure we don't lose any, right? So what we're doing is we're going to, you know what? I need to give everybody a really good view of this because these stacks can be a pain in the rear for people. So working on this one here, and we got the shim in, first bearing on like that with basically our I don't know what you call that, the ridge. We'll just call it ridge, with the ridge side down. And this is very common. Next one's gonna be like this. Basically what we've done there is we've made a place for the belt to ride on the bearings there between those two. And again, there's a little bit of play there, but it's also not touching the plastic because we have that little tiny washer shim in there. So that's good all the way around. So after that, we're putting not one, but two of these shims. So at this point in the stack, we are, what, 6/100ths off? All right, so we got that. All right, so now we're gonna do the same stack again. It's gonna be for the other belt because it's Core XY. It's gonna be two belts that go by each other. So a little space in between there, but they're going to spin freely. There we go. And then another washer right on top there. And that is that stack. So that stack with the double, or the quad bearings or the double rollers there for our belt to glide past. Nice. Okay, I'm gonna spin this around. Now I'm working on the one here. This is the one with the protrusion on the bottom. So that one starts off with a little, whoop, if I don't drop it here, a little printed spacer. So that's gonna go on like that. That's our printed spacer. You know what? I just messed this up already. All right, check it out. I just did this backwards. No harm, no foul. We will fix it right now. I was trying to figure out, like, why would there be a space? So it's one of those things. Use your mind as you're building this, right? So I just made a mistake. Like I said before, I already mentioned it. Building this live, never done it before. But I'm using my brain. I was thinking to myself, why do I need a spacer on this one since it's actually doesn't have anything behind it to hold it back or anything like that? Why wouldn't the spacer be another one? That's when I noticed that I'm wrong. The spacer goes on this guy, not this guy. So I'm gonna build that stack again on this one. So give me one quick second on that. So right there, the two. There. These stacks are used on the Voron printers often. Up one on the very top there. And if you were a little bit of a worrywart like I am, you might even decide temporarily put yourself a little nut on top of that so you can't lose it now that you have it built. So right there, we're back. Okay, so that's where it needs to be. I apologize for that. Basically what I did is I inverted these two stacks. First I built that stack on that one. Now it is on the correct post, which is this one with the protrusion coming out the bottom. Next one's going to be with the spacer. So here we go with that. So this one, it starts with the spacer and then a washer. Like so. And then we're going to make a single stack. And then another single washer. Like so. There we go. And throw a nut on that real quick. Can't lose it. There we go. I take these guys and I'm going to put them in my empty container. Sure, we'll be using them on the B side. So let's get back to actually we want this way. Oh, no. There we go. All right, so we just did that. It's all 6 spacers identical. We won't call out moving forward. So what they're basically saying is that picture is a printed spacer. They're not going to call it a printed spacer moving forward. You're just expected to know. So as you work your way down through the manual, you'll see it. It says for ease of assembly, recommend assembly of A and B drives upside down. I totally agree. All right, so now what we're going to wind up doing is basically attaching our tops and bottoms together. That's going to be pretty basic, so let's do that real quick. So, yeah, this is the Voron 0.1 LDO kit. I'm going to take these two nuts off that I put on before. This is the AB drive, and I'm going to hold it approximately like it is on my screen. Oh. I put that in afterwards. Oh. Good stuff here, huh? Alright, put this nut back on real quick. Like my screw. All play nice. So what I'm going to do is I'm going to use a screw behind it, push it up, so I don't lose that again. And I'm going to hold it. I'm going to hold it like that. Oh. Oh man, fun times had by all. All right, I know what I'm doing though. That third time's a charm, right? double in the middle. Don't forget the double in the middle. All right, let's nut back off. There we go. All right, so now I'm gonna hold this basically like they have in the manual. This is going to go similar to that, and we're going to basically be pushing that. Get ourselves a little sandwich, and again I'm going to put these nuts on real quick to hold it. Nuts will just hold it temporarily. I won't say anything about that, but let's just call it a hunch. I'm actually going to there we go. Take that screw out. Now we don't need that. Our bearing stack should be good. We have what I can only assume is going to be a tension adjustment. Pretty cool. Geek out on some of these parts. This thing's so neat you can build it yourself, right? All right, back to our screen. All right, so we just built that. Notice they don't have nuts on there. Those nuts are gonna come off. I just put them on there to hold my piece together because I am a klutz, as we just saw. All right, so we're gonna need two M3x30s. We know we have 35s and 30s. I got two 30s in my contrast material down here, and then some 35s, 435s, and then we're going to use that. All right, so let's see here. We're going to hold this like so, and we're going to insert our 30 screws so they should on here. Maybe? Oh, I see. It's offset. Alright. Right like that. And our other one is right here. Get that turned all the way down, by the way. You don't want it. Whenever you're screwing in the plastic, remember you're screwing in the plastic. You don't want to go too far. Bend, main, destroy, all those bad things. All right, so that's that. What I'm going to do is I'm going to put a little PTFE. It's not called out, but I can pretty much guarantee somebody will call me out for doing this. I'm going to put a little PTFE grease on this guy, just like tiny smidge. The reason why I'm using PTFE grease is because it is safe for plastics. I'm sure there's other lubrications you could use. This is what I've had luck with in the past. It's pretty popular. The aforementioned crowds of 3D printing people. Probably could do it slightly better if I'd done it before I put it in, but this is an afterthought. I guess one of the benefits of watching a video like mine is less afterthoughts, right? We will remember to do that for for our B drive though, right? All right, so let's tighten that back up again. All right. All right, it's not too bad. Better than it was. It will suffice. Always loosen those up a little bit. We need to loosen those up just a little bit. Ah. There we go. Perfect. All right, good. All right, now back to El Screeno. All right, so now they want us to put in our, well, first thing first, we got to do the G2 20-tooth pulley, which was inside of our box of magic tricks. And they have a very specific grub screws, aka the root of all issues. Yeah. Use ThreadLocker on all grub screws. Loose grub screws account for a large percentage of issues that users report. Save yourself hours of troubleshooting. Apply ThreadLocker to all grub screws during your build. See products application notes for instructions. Alright, so grub screws. I want to talk about that for a second, because if you use the liquid, and this is blue ThreadLocker, this is a Zap product one, but I mean it's all the same, Loctite, Zap. If you use a liquid on your grub screw, it's so small it's hard to get just enough on there. It's going to wind up on the shaft of your stepper, and it's funny because it will lock your pulley onto your stepper without the grub screw. It's like glue. So I suggest you get some paste, and I may have mentioned already in this build. I definitely mentioned in a previous build of my Voron. I love this stuff. I'll try to put a link to this on Amazon in the comments below, but very helpful. If you're not familiar, it's kind of like a chapstick for Loctite, right? Don't do that. All right, so we need that. We need our grub screws. Which grub screws are these? Oh man! Wow, look at that. Looky. The fine folks at LDO have already applied some blue Loctite or similar product to these grub screws. So I do not need to apply it. That's a nice touch. So let's grab probably two of these, I'm guessing. One's going to go on the spine and one's going to go on the shaft without the spline on it. So flat surface here, round surface around the rest. And we just need to make sure one of our grub screws is on that flat surface. Let's get that started. Just going to get enough tension on it so that it holds itself up. Also, we'll keep enough tension on it so it doesn't move from that flat spot. Stay there. Let's see that one better. So that's there. It's going to hold itself up. All right, so they're calling out 8.5 millimeters on that. so we will actually measure that. It's gonna be hard to get in there, but we will try on 0. .5, huh? Is that okay? So it's 8.5. Oh man, that's difficult. Why they got to do that? So they're calling out 8.5 from the actual base of the stepper, not from the ring here. So I guess what we will do is we're at about 7.7. We need to be at 8.5. So let's just put this at 8.5. Tighten that up. Up our grubbies. Just loose enough so I can slide it. I don't want to be able to move it easily. Down to like a 1/8 of a turn, not even an 1/8, like a 1/10 of a turn here. There we go. Alright, so 8.5. Just right about there. Yep. Up 2 on these, and pretty much only these. I like to switch this over, just get like another like 10% on them. Right, double check that before I finish that. Yep, right there. Good. All right, turn it off. Let's it back up. Get rid of it. I'm sure we're gonna need it again when we do the B, but there we go. And what I was mentioning on that, just so I can point out, is they're calling out 8.5, but they're doing it from the shoulder here, not from the extension. So it's 8.5. And again, it's just weird the way they're doing this. Okay, so it's 8.5 from there to the inside of the where that's riding. So I'm not even 100% sure I'm right yet. So let me look at this real quick. Again, just one more time. 8.5. 8.5. I got it upside down anyways. Yep, so I gotta take it off anyways, so let's see. That's why I should do more live streams so everybody can yell at me when I make mistakes. So we're actually putting this way. This might make a little bit more sense. Yep, it does. It does. Alright. So 8.5, 8.5, 8.5 on this stepper with this pulley pretty much, not exactly, I learned that the hard way on another printer, pretty much puts this flush with the end here. It's not exactly flush. Proud just slightly of it, but it's pretty darn close. So there we go. All right, so let's tighten that up real quick. All right, so there we go. All right, now thought we have to dig into the CAD. Ugh. Let's see, we did that, we did that. Now leave the screws slightly loose, tighten them fully, we'll lock the tension adjustment. Oh, okay. So they're talking about what we just did, where we loosened up our screws after we lubed up the tensioner. So, yeah. All right. So let's get back to this right here. So now what we're going to do is we're going to use our M3 by 35s. There, M3 by 35s, which are called out up here, to attach our component, which is right like this, to the actual stepper. So we're going to put them in these elongated pathways, which mesh up with tensioner. That, and then that's going to be sitting on top like this. Now, here's the real question: which way do we want the wires coming out? So none of these manuals ever show you where the wires go, and you got about a, well, in this particular case, 25% chance of getting it right. So, as much as I hate to do it, we're gonna have to get into the CAD. I had a feeling we have to do this. So why don't I get that? Do that. All right. So this is Fusion 360. If you don't have Fusion 360, you should get a copy of it. It's free as long as you're not using it for commercial use. Works really well. It's a special tool. But I've gotten rid of everything here, and all I have is our part that we have right now. But on the CAD drawing, they also don't show wiring coming out of it, and it's probably because depending on where you get your stepper will determine where that wire is coming out. So I need to turn on some other things so we can kind of see where this is going to be sitting to make sure we don't put wiring coming out of it where we don't want it. So bear with me here as I kind of get, let's see, we don't need that. We don't need skirts. What we need see, idlers. We don't need that. We don't need that either. Frame, we do need that. Okay, that should be good. Where are the panels? Panels. Where are those panels? Where's the panels? MU panels? Spool holder, skirts, pocket watch, electronics. Oh, here we go. Panels. Alright, so that's the back. Okay. So it looks like we probably would have enough room coming out the back side. Definitely don't have enough room coming out this way because that motor's right up against that. So I'm gonna face mine towards the back, and that's an educated guess. Probably 80% sure that will work. Another reason I'm doing the back as opposed to doing something like the front is because if I do the front, whoa, gonna lose my, spacing here. If I do it off to the front or the back I guess the side or the front, is I'm gonna have to find some place to run that wiring. Better chance not that wiring I can run straight down through here. So it's gonna come off here and go down that way. That's my guess. That's what I'm going to do. So that's what we will do. Now, what does that mean? That means that this knob, that means that this is sitting in the printer like this. So we're going to affix this like this. Let's do that. All right. So this is how I am going to put this together. So bearings are here. Wiring coming off this backside like that. And this is our tensioner over here. And then that means my wiring, if I put it along the rail, is going to go down like that. So I think that's how I'm going to do it. We can always change it if we have to later down the road. All right, so let's do it. Better time than the present, right? Actually over tighten these real quick, and then I'm going to loosen them back up by hand. And that way I have a better feel for how they're in there. Okay. I wouldn't say that's easy to move, but I would say you probably want it to be easy to move. I mean, this will start to wear over time anyways, so there we go. Happy with that. Okay, and just to double check, let me just double check on my CAD here again. Let's look. Oh, we have that. Oh, apologize. So the way I have this, if I'm correct, is the nut eventually is going to go on this end over here. It's our tensioner. Our wire is coming off the back, so the back being right here, and that will allow me to loop this wire down and down this way. That's my guess. Bingo bambo. All right, what is next? What is up? What are we doing? All right, so let's see here. A drive. Okay, we'll put the nut on there. Pardon the manual. I kind of threw the nut on there real quick anyways. Check your work. Compare your assembled parts to the graphics shown here. Pay attention to the pulley orientation. And pay attention to stack. All right, let's double check that real quick. So what they want us to do is double check our stacks to make sure they look like they do there, with basically our single stack over here with our pulley on top, which we have. Putting everything backwards here with my hands, by the way. It's real fun, huh? Building one of these on a video and doing it for your first time when you're not a professional YouTube printer builder builds character. All right, so we got that, and then we got our double stack, and you guys can probably see better than I can, but down inside there we have our pulley, which is facing the right way. So I say our work is correct. All right. What is next? B drive. Okay, let's look at this real quick. I don't want to make this a 2-hour video, so spare everybody a little bit. Let's just go through real quick, make sure everything's the same. If it isn't, we'll take a look, we'll discuss it real quick, and move on with our day, huh? All right, so heat set inserts, replay. You can rewind, play this backwards if you want, you know, B versus the A. That goes in. That one, that 235, that is the same. But do notice how they're not calling out that that's a printed spacer. They mention it, they give you fair warning. So when you get to that, if you had a day or two or a week or something like that, or you had to go to work and you left for a while and you came back and said, what the hell is that part right there? Look back. All right, so upside down assembly, same notes there. This is the same. Okay, so this is what I was thinking. This is the same on this right here is pretty much the exact same thing that happens on the 2.4, and I'm guessing any Core XY printer from the Voron team, and just because of the way Core XY works, possibly anything with like an AB drive is going to be this way. So basically, on this one, on this B drive, you're actually putting your pulley on upside down or right side up from the way I did it the first way. I could have used my pulley scenario with my motor as the B drive as opposed to the A drive, and we could have called it a day. But please note that is going to go the other way around, and now as opposed to the 8.5, we're at 17.5, and again, it's going to be almost flush with the top there, but may not be perfectly flush with the top. So pay attention to that. Try to get your 17.5. And when you come down to doing your final tuning when you're printing with this, if you notice any weird noises, what I suggest you do, and maybe we'll get into this a little bit later, but is print a large rectangle on your printer. And I say that because that will cause your belts to move faster than they normally would. If you do that in vase mode, base mode, whatever, it will cause the belts to ride up almost instantaneously if they're going to, and you'll hear that clunky jumping sound. And if you see that, then you can stop it. You can move by hand, disconnect your steppers first, and you can see if that belt is kind of jumping up on this lip right here or on the other one on the other lip, and it will cause belt degradation over time. But if you catch it early, you can kind of adjust that. You loosen up your grub screws and you adjust the height on these a little bit. You're probably going to have to do that no matter how good you are in terms of getting this right, because these might be slightly off from how your printer exactly is. These are custom built machines. There are little differences. So okay, they're doing the same thing here. Don't over tighten, blah blah blah. Check your work, good there. And then we're gonna put them on the printer. Awesome. All right, so there you have it. It's been a great episode. I haven't mentioned yet, but if you haven't subscribed, please do so. Hit that like button, that notification down there. Again, down here, this is the Voron LDO AB drive video for my channel. And if you have comments, questions, anything like that, I knowingly and have in the past and continue to do so to answer questions within 24 hours if you ask them of me. Always willing to reach out and lend a hand. I've even helped some people via email. So just reach out if you have any questions. Also check the description. I'll have some affiliate links down there for a couple of parts and tools that I use. They help me out a little bit if you do decide to buy something on Amazon or AliExpress. I do appreciate that. So yeah, I guess that'll do it. See you next time.